Hi, good morning. കഴിഞ്ഞ ദിവസം നമ്മൾ റെക്കറൻസ് റിലേഷൻ ഇൻട്രൊഡ്യൂസ് ചെയ്തപ്പോൾ ഒരു എക്സാമ്പിളിൽ നമുക്ക് ഇങ്ങനെ ഒരു റെക്കറൻസ് റിലേഷൻ കിട്ടിയായിരുന്നു. an is equal to an minus 1 plus an minus 2. And we define the recurrence relation for a sequence AR is an expression giving the nth term in terms of sum of its previous terms. That is what is known as a recurrence relation. And we have the initial conditions a1 equal to 1 and a2 equal to 2. Then we solved this recurrence relation for any n. That means we found the value of an for any n. അത് നമ്മൾ കണ്ടുപിടിച്ചത് an is equal to an minus 1 plus an minus 2 എന്ന് പറയുന്ന ഫോർമുല റെക്കഴ്സീവ്ലി അപ്ലൈ ചെയ്ത് we arrive at finally in terms of a1 and a2. അതായത് പുറകിലേക്ക് വരിക. This an is a very far front term. So for example a10 is reduced to a9 and a8, then further a9 and a8 in terms of a8 and a7. So we are going to back, and this type of solution, so we can find a10 and we can find any an for any n, and this solution is obtained by going to the back. Finally we reach at a1 and a2. Then spell what is an, and this is known as backward solution. And we see from our experience itself that it is very tedious and time consuming. So we need to have a solution, a general solution to a recurrence relation. ഇങ്ങനെ ഒരു ബാക്ക്വേർഡ് രീതിയിലേക്ക് പോകാതെ മറ്റെന്തെങ്കിലും ടെക്നിക്ക് ഉപയോഗിച്ച് പെട്ടെന്ന് പറയാൻ പറ്റുന്ന ഒരു സൊല്യൂഷൻ പറയാൻ പറ്റുന്ന ഒരു മെത്തേഡ് ഉണ്ടാവണം. So we have to develop that. And in fact we see there are several types of solutions, several type of recurrence relations. See, an by an minus 1 is equal to 1 by an plus 1, 1 by an minus 2. That is also an expression giving an in terms of an minus 1 and an minus 2 and so on. Now, a recurrence relation of this form, c naught an plus c1 an minus 1 plus c2 an minus 2 plus etc. plus cr an minus r equal to 0, where c naught, c1, c2, etc. cr are constants. Ca's are constants. And this is also a recurrence relation because an is given in terms of the previous terms. And a recurrence relation of this form is known as a linear homogeneous recurrence relation. Linear homogeneous recurrence relation, and we study here how to solve a linear homogeneous recurrence relation. Okay, these c naught, crs are constants and cr not equal to 0. CR not equal to 0, and this is known as an rth order linear homogeneous recurrence relation. Rth order linear homogeneous recurrence relation. So our first problem is how to solve an rth order linear homogeneous recurrence relation. So we follow these steps. Let c naught an plus c1 an minus plus c2 an minus 2 plus etc. plus cr an minus r equal to 0, be the linear homogeneous recurrence relation. We replace AI by x raised to I. Now the equation becomes C0 x raised to n plus C1 x raised to n minus 1 plus etc. plus CR x raised to n minus r equal to 0. Now x raised to n minus r can be taken outside and we cancel throughout x raised to n minus r. Cancel throughout x raised to n minus r gives x C0 x raised to r plus C1 x raised to r minus 1 plus etc. plus CR equal to 0. ഇതുകൊണ്ടാണ് നമ്മൾ നേരത്തെ CR 0 ആകരുത് എന്ന് പറഞ്ഞത്. കാരണം CR 0 ആയി പോയാൽ we can cancel one more x throughout. Then it cannot be rth order, it will be r minus 1th order. This equation, this is known as the characteristic equation of the linear homogeneous recurrence relation. Now solve these characteristic equation. Solve the characteristic equation and get characteristic roots. So the roots of the characteristic equation are called characteristic roots. Since this is an equation of rth degree, we get r roots. Then there are two possibilities. So we get r characteristic roots. Then there are two possibilities. All the roots are distinct. See, if all the roots are distinct, say alpha 1, alpha 2, etc., alpha r be the r distinct r be the r be the all r distinct roots of this equation. Be the r distinct roots of equation 1. Then the general solution to equate the recurrence relation is given by an is equal to a1 alpha 1 raised to n plus a2 alpha 2 raised to n plus etc. plus ar alpha r raised to n. അതായത് തന്നിട്ടുള്ള ലീനിയർ ഹോമോജീനിയസ് റെഫറൻസ് റിലേഷനകത്ത് എ ഐകൾക്ക് എക്സ് റൈസ് ടു ഐ കൊടുത്തിട്ട് എക്സ് റൈസ് ടു എൻ മൈനസ് ആർ ത്രൂ ഔട്ട് ക്യാൻസൽ ചെയ്ത് ഒരു ഇക്വേഷൻ ഫോം ചെയ്യുക. That equation is what is known as characteristic equation. Solve the characteristic equation and get the characteristic roots. Then rth degree equation r rootകളും distinct ആണെങ്കിൽ, if all the roots are distinct, say alpha 1, alpha 2, etc., alpha r be the all r distinct roots of 1, then the general solution to the homogeneous recurrence relation is given by these, where ai's are constants which are to be determined from initial conditions. ഇനി പ്രശ്നം വരുന്നത് ചില റൂട്ടുകൾ റിപ്പീറ്റ് ചെയ്യുമ്പോഴാണ്. നെക്സ്റ്റ് അസ്യൂം some roots repeat. So suppose alpha 1, alpha 2, etc., alpha k be the k distinct roots where 1 less than or equal to k less than or equal to r. ചിലപ്പോൾ ഒരു ഡിസ്റ്റിങ് റൂട്ടേ ഉണ്ടാവും, ഒരു റൂട്ട് മാത്രമേ റിപ്പീറ്റ് ചെയ്യത്തുള്ളൂ. So let alpha 1, alpha 2, etc. alpha k be the k distinct roots with multiplicities m1, m2, etc. mk. Then the general solution is given by an is equal to a11 plus a12 n plus a13 n square plus etc. plus a1 m1 n raised to m1 minus 1 alpha 1 raised to n. ഇതേപോലുള്ള സിമിലർ ടേംസ് ബാക്കിയുള്ള ടേംസിന് കറസ്പോണ്ടിങ് ആയിട്ട് a21 പ്ലസ് a22n പ്ലസ് a23 n സ്ക്വയർ പ്ലസ് എക്സെട്ര പ്ലസ് a2m2 n റൈസ് ടു m2 മൈനസ് 1 ആൽഫ 2 റൈസ് ടു n പ്ലസ് എക്സെട്ര പ്ലസ് a mk a k1 plus a k2n plus a k3 n square plus etc. plus a k mk n raised to mk minus 1 alpha k raised to n. So if alpha 1 is of multiplicity m1, then we associate with alpha 1 raised to n a polynomial in degree m1 minus 1. A polynomial in n of degree m1 minus 1. So if alpha I is a root with multiplicity mi, then associated with this alpha I, we associate a polynomial in n of degree mi minus 1. This similar treatment differential equation solve ചെയ്യുന്ന സ്ഥലങ്ങളിൽ നമ്മൾ പഠിച്ചിട്ടുണ്ട്. The same thing. Here where aij's are constants to be determined from initial conditions. So this is the general theory of solving a linear homogeneous recurrence relation. First write the linear homogeneous recurrence relation. Replace a is by x raised to I. Cancel throughout the highest, the power of x. The smallest power of x is cancelled throughout. Then from the characteristic equation, solve the characteristic equation to get the characteristic roots and write the general solution depending upon the nature of these characteristic roots. If all the roots are distinct, then an equal to a1 alpha 1 raised to n plus a2 alpha 2 raised to n plus etc. plus ar alpha raised to n, where these ai's are constants, forms a solution. And if the roots repeat, say alpha I repeats mi times, then corresponding to alpha I raised to n, we associate a polynomial of degree mi minus 1 with that. And these constants in two cases can be obtained from the initial conditions. A backward method ഉപയോഗിച്ച് solve ചെയ്യാൻ ശ്രമിച്ച recurrence relation നമുക്കൊന്ന് solve ചെയ്ത് നോക്കാം അവിടെ as an example. This is all an equal to an minus 1 plus an minus 2 subject to the initial condition a0 equal to 1 and a1 equal to 1. ഇവിടെ പ്രശ്നമില്ല, കാരണം നമ്മൾ കഴിഞ്ഞ ദിവസം a2 equal to 2 എന്ന് കിട്ടിയായിരുന്നു. And this a2 is equal to a0 plus a1. This satisfies the recurrence relation. So we add a new initial condition a0 equal to 1 for computational purpose. Okay, first we write this in the linear homogeneous recurrence relation form. The given equation is an minus 1 minus an minus 2 equal to 0. This is a linear homogeneous recurrence relation. So replace an by x raised to n. Replace ai by x raised to I implies x raised to n minus x raised to n minus 1 minus x raised to n minus 2 equal to 0. Now you cancel throughout x raised to n minus 2. implies x square minus x minus 1 equal to 0 is the characteristic equation. Now solve this. When we solve this, we get this is 1 plus or minus square root of 5 by 2. So alpha 1 is equal to 1 plus square root of 5 by 2. Alpha 2 equal to 1 minus square root of 5 by 2. And these are distinct. Distinct. Therefore, the general solution is an is equal to capital A. And constants A1 A2. We call it as A and B. Capital A alpha 1 raised to n plus capital B alpha 2 raised to n. So this is equal to capital A 1 plus root 5 by 2 the all raised to n plus B 1 minus root 5 by 2 the all raised to n, where these A and B are constants to be determined using the initial condition. Now, what are the initial conditions? A not equal to 1 implies A plus B equal to 1. A1 equal to 1 implies A into 1 plus root 5 by 2 plus B into 1 minus root 5 by 2 is equal to 1. We call this as 2 and 3. We solve these two equations A and B for A and B. ആദ്യത്തെ രണ്ടാമത്തെ ഇക്വേഷനെ 1 plus root 5 by 2 കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്ത് രണ്ടാമത്തെ ഇക്വേഷനെ മീൻസ് ഇക്വേഷൻ 2-നെ 1 plus root 5 by 2 കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്യുക, സബ്ട്രാക്ട് ചെയ്യുക, സിംപ്ലിഫൈ ചെയ്യുക. We will get B as minus 1 minus square root of 5 by 2. And A, on solving this, we will get 1 plus root 5 by, so we get this as 1 minus root 5 by 2 root 5, and this as 1 plus root 5 by 2 root 5. This is what we are going to get. Now substitute this in this equation. We have an is equal to A into 1 plus root 5 by 2. We get the general solution as an is equal to 1 plus root 5 by 2 root 5 into 1 plus root 5 by 2 the all raised to n plus minus 1 minus root 5 by 2 root 5 into 1 minus root 5 by 2 the all raised to n. So this is equal to 1 by root 5 into 1 plus root 5 by 2 the all raised to n plus 1 minus 1 minus root 5 by 2 the all raised to n plus 1. N equal to 0, 1, 2, 3, etc. See, this is the general solution. And this is the general solution. Now, see, we have seen that this reconciliation satisfies n equal to n minus 1 plus n minus 2, beginning with a not equal to 0. So we get the solution a not equal to 1. We get the sequence as 1, 1, 2, 3, 5, 8, 13, etc. And this sequence is known as the Fibonacci sequence. Fibonacci sequence. Another question. Solve an equal to 6an minus 1 minus 9an minus 2. subject to the condition a naught equal to 2 and a1 equal to 3. Here also we write this as an minus 6 an minus 1 minus 9 sorry, plus 9 an minus 2 equal to 0. So that the characteristic equation is x raised to n minus 6 x raised to n minus 1 plus 9 x raised to n minus 2 equal to 0, which implies x squared minus 6x plus 9 equal to 0 is the characteristic equation. That is x minus 3 the whole square equal to 0. Therefore, x is equal to 3, 3 are the characteristic roots. They are not distinct, but one root with multiplicity 2. Therefore, the general solution, 3 raised to n in corresponding and we associate a polynomial of degree 1 in n. 3 multiplicity 2 ആയതുകൊണ്ട്. Therefore, an is equal to a plus nb 3 raised to n is the general solution. Where a and b are constants which are to be determined. Using the initial condition a naught equal to 2 gives a equal to 2. Then n equal to 0. N equal to 0 here this is 1, so a equal to 2. A1 equal to 3 implies a plus b into 3 equal to 3. Okay, therefore a is 2, 2 plus b equal to 1. Therefore, b is equal to minus 1. Therefore, the general solution is an is equal to a is 2 minus n, 2 minus n into 3 raised to n. This is the general solution. Text question number 1, 2. Seven. That's a homework. Question number 1 to 7. Okay, thank you.